summation notations, okay? Summation notation. Review and exercises. So in the lecture that Jordy did on Thursday, so on week 1, everything that's on that lecture you will see during the year. So you should really get familiar with all of those. In this section, what I want to do is give you a few exercises on things that people get incorrectly quite often, and I want to get a sense of how people can work on this. So let's try with question 1. Imagine that I give you this question: sum of xi minus x bar, yi minus y bar, divided by sum of xi minus x bar squared. Now I'm being a bit lazy here because really what I should be doing is I should also tell you that this summation notation is over I from 1 to n, I from 1 to n. But if I'm lazy that way, you should assume that that's what's happening, right? That that's just a summation notation from I1 to n. Here's my question for you. I would like to simplify this expression. Simplify. Can I do this? Can I say, well, actually, this is xi minus x bar, this is xi minus x bar, but squared. So I will simplify this expression by just doing this. Can I do that? How many of you think that we can do that? Show of hands. How many of you are uncertain? How many of you think that we cannot do that? Okay, we definitely cannot do that. Very good. We cannot do that because doing that is the same thing as doing something like this. 3 times 2 plus 5 times 6 plus 11 times 22 over 3 square plus 5 square plus 11 square. Look at the similarities between that, right? The 3 is here and the 3 is here. The 5 is here and the 5 is here. The 11th is here and the 11th is here. Just as it was up there, right? But if I do something like this, you will laugh at me, wouldn't you? The thing is that I've seen people do this quite a few times, right? So just keep in mind what the meaning of that summation notation is. And if you know the meaning of that summation notation, you are not going to do such mistakes. Here's the next exercise. 2. What is sum of y bar xi minus x bar times 4.5? Of course, I'm being lazy. I should say I going from 1 to n. See if I give you 1 minute. Simplify this as much as possible. Simplify this as much as possible. Of course, x bar is nothing but sum of xi divided by n. It's the arithmetic mean. If you have an answer, just give me a hint. A show of hand. Mara, what do you have?
20y bar multiplied by sum of xy minus.
Okay, we can go even further. Anyone else has a different answer? Anyone else has an answer for this? That it's a lot simpler? Okay, let's do this together. Does this 4.5 change as I change the terms of that summation notation? No. So what can I do with constants? I can pull them out. So I can pull this out because it's a constant, doesn't change. Does y bar change with each term? No. How do you know? Dominic, how do you know? Well, y bar is actually not a constant, it's a sample mean. Every time you're going to change the sample, it's going to change as well. So y bar is actually not a constant. It's a random variable that will change every time you change the sample. But what allows me to pull that out? So y bar is not a constant, but what allows me to pull it out? It doesn't have an I, so it will not change on each term. It doesn't really mean that we can only pull out constants, but we can pull out anything that doesn't change across terms. Okay, so this y bar does not have an I. Does not have an I. Note, it's a random variable, it will change. You actually don't know the value of it, but because it's the same for each term, I can pull it out. So this can be pulled out as well. So I can write this as y bar times 4.5 sum of xi minus x bar. Okay? Now, here's one thing that you should know. Y bar times 4.5, this can be rewritten as sum of xi minus sum of x bar. Okay? Everybody's with me? Now, anyone can tell me what is the sum of x bar? N times x bar. N times x bar. Here's one thing that you probably don't know. How could you rewrite this, or that probably doesn't come naturally, how could you rewrite that as a function of x bar? How could you rewrite sum of xi as a function of x bar? Yeah. X bar times n, right? Why? Look at this formula. If I just want this part here, I just multiply both sides by n. So this bit here is also n times x bar minus y bar times 4.5. But what do you know about this expression here? This expression here is 0, of course. So one rule that you will see happening over and over again is that the sum of xi minus x bar is going to be equal to 0. More generally, the sum of xi minus x bar times anything constant will also be equal to 0. Everybody with me? Here's another trick question. It's not really a trick question. It should be hopefully straightforward, but I see people making mistakes on this all the time. What's the sum I from 1 to 3 of 3? Sherman? 3. Amory? What's the sum of 1 to 3 of 3?
3.
3. Devin, what's the sum of 1 to 3 of 3?
3.
3. Mara, what's the sum of 1 to 3 of 3? 9. Angela, what's the sum of 1 to 3 of 3?
0.
0. Anna, 3. Yeah, next. What do you think? 18. Wow. Christina, what do you think? You're uncertain?
3.
3. Sherman? I asked you already. What do you think? Dominic? 3 as well. 3 is winning. What do you think? 6. Wow. This is a great exercise. What do you think?
3.
3 for you as well? Okay. What do you think? 3. What do you think?
3.
3. Well, if math was democracy, 3 would have won, clearly, right? But math doesn't care about democracy, right? Now, clearly, there is only one right answer. We cannot have 1, 2, 3, 4, 5 different answers, okay? You need to know the rules of summation notation, okay? You need to understand that every time I sum, let's say j from 1 to n, of something that is not with j, this could be a very long expression. What this is you write that expression c plus c plus c plus how many times? N times. So when you have something like this is just n times c. Now, When I ask you what this was, right? Mara rightfully said x bar, well, x bar is a constant, so I'm summing up a constant n times, so that must be n times x bar. Okay? What is this? 3. What am I doing? I'm summing up a constant 3 times. If you write this out, this is 3 plus 3 plus 3. It is not 3. It is not 0. It is not 18. And it is definitely not 6. But it is 9. You want to get up to speed with this kind of things, right? This exercise shows that you have some gaps there, right? And actually, most of you have some gaps in the summation notation, but they're very easy to fix. They're very, very easy to fix, and you want to fix them fairly quickly, okay? Here's another question. 4. I'll give you 2 expressions. Again, I'm being lazy. I'll keep on being lazy. I'm not going to say, but it's I, okay? Call this expression A. Call this expression B. Which one is larger? Which of the above is larger? I want you to do this individually. I want you to pick an A or B. We're going to take a poll, okay? Which of those two is going to be larger, A or B? You don't have to solve it. You could also see it if you could just see it. Ready for a vote? How many of you think that A is larger? For a show of hands. No one. How many of you think that B is larger? With a show of hands. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11. How many of you are uncertain? 1, 2. How many of you have a different answer? Okay, can I hear from the different answer ones?
None of them.
None of them. They're both the same. Very good. Why are they both the same?
They're both 0.
No, there's actually, okay, fine. You're thinking that both of them are 0. That's why you think of them as being the same. That's not the answer. That's not the case. They don't have to be 0. Yeah, Devin?
Isn't that they're both undefined because they have 0 on the denominator?
You have no idea of knowing that. The only way you could have gotten 0 on the denominator is if it's all the xi's were 0. Any other cases, you wouldn't have that. Anna?
Maybe because one of the properties is that the upper part of A is the same as the upper part.
Maybe there is some property, but you might want to remember that property from scratch. Let me tell you that actually you should already know this. But it's a very common occurrence. Let's work on this together. This is, I can rewrite this as sum of xi minus x bar times yi minus sum of xi minus x bar times y bar. Can you all see that? Right? I can do that, right? Because all I'm doing is I'm multiplying this with this and this with this, and I'm just opening up the summation notation. I can do that. That's another property of the summation notation, right? But what do you know about this part? Zero. We just did it. So A and B are the same thing. This expression has created a lot of headaches in the in the past years of MG205. So I'm trying to remove any potential future headaches. So if you follow up with the classes, if you go to the videos and you review them and you redo them, hopefully we'll make this course an easy one rather than a challenging one. Right? But it's a lot of work. Okay, everybody with me? So A is not bigger, B is not bigger. They're exactly the same. What am I using? Exactly the same thing as before. Okay, exactly the same thing as before. Let's try another one. 5. Sum I going from 1 to n of xi minus x bar times zi is equal to 0. True or false? 10 seconds. See if you can decide whether that's true or false. And we'll take a vote. Okay, show of hands. How many of you think that that is true? 1. How many of you think that that is false? 2, 3, maybe 4, maybe 5. How many of you are uncertain? We got a few people that are uncertain, and that's okay. What you need to realize is that this statement is false. And you can easily convince yourself of that statement being false, because this zi is not constant, so I cannot pull it out. The only thing that I learned from here is that this thing had to be a constant. If it's not a constant, that's not a property. I cannot use it. Let me illustrate this with an example. Let me take the values of -1, 0, and 1. Let's say that this is my x1, this is my x2, this is my x3. What is x bar? Well, -1 plus 0 plus 1 over 3, which is equal to 0. So what is the sum of xi minus x bar? I going from 1 to 3. Well, of course, this always is 0, but you convince yourself that's going to be 0. Right? Now, what I'm asking you is, if this is 0, could this be 0? -1 times z1 plus 0 times z2 plus 1 times z3. Is this equal to 0? Of course, if I gave you something like that, what would you say? Well, it depends on z. That's what you would have said. If z1 is the same as z3, that would be true, but it's not always true. So be mindful of this property coming up that way. Now, what you should realize is this, that you actually don't know summation notations very well, okay? Overall. And you're going to see them in this course all the time, right? And accepting that you don't know them is the first step. The second step, just as important, is going out and practicing, okay? So let me give you one resource. So more exercises. And there's a theory that the Europeans evolved a lot quicker than the other parts of the world, because at some point they realized that they were ignorant, they didn't know stuff. So they admitted to themselves that they didn't know, right? And then they went out and looked for answers, right? So that's always the first step. But if you wanted more exercise, it's very easy. You go to this Khan Academy, which is a wonderful place to just practice your math, like basic tools that you're going to need. And all you have to go is go here and say, well, I would really like to practice summation notation. And then go to exercises. And then summation notation. Let's try to do this. Okay, see if you can do it in your own head. 10 seconds, we'll take a poll whether it's A, B, or C. How many of you think that it is A? Okay, 1, 2, 3, about 6. How many of you think that it is B? How many of you think that it's none of the above? A few. I've kind of tricked you by now to kind of be skeptical of any questions I throw at you. So I think you're being very skeptical about things. The answer is, of course, open this up. If m is equal to 0, what does the inside become? 0 over 4, which is the first term, right? If m is equal to 1, what does this become? 1 over 4, which is 0.25. If m is equal to 3 or 2, this becomes 2 over 4, which is 0.5. It's equal to 3, 3/4, 375. So of course the right answer is A. And if you did this, check. Nice work. Keep going, right? So you want to do that, right? So you want to practice. And I don't know of any better place to practice, right? So you try and you do a few exercises and you can watch videos and things if you get stuck or anything of that sort. There's no reason why it shouldn't be fantastic at summation notations. Like there should be no property of summation notation, there's not many of them, that you should know inside out. Okay? So on that note, I'll finish this section on summation notations.